everyone. My name is Dee Zeiss, and I am the host of the KubeChat webinar series. So welcome to today's session. Today's title is Managing Kubernetes Resource Quotas with IBM Kubecost. Before we get started, I just wanted to cover a couple of housekeeping things. So we are recording today's session, so if you cannot stay for the whole thing or want to share it with others, we'll send out a recording to your email that you registered with tomorrow. So be on the lookout for that. We'll also paste a recording of it on our website, so you can find it there. We also have a PDF of today's webinar on your console there. So if you want to download it and follow along, feel free. There's also a couple links throughout there that you can click on as we're scrolling through here. And then you'll also find a Q&A feature on your console. So we'll save about 10 minutes at the end for any questions that you have. So feel free to submit those throughout, and we'll cover as many as we can once we get to the end. So moving on to the agenda here, we'll just start off with some brief introductions about our speakers as well as Kubecost. Then we're going to really get into what Kubernetes resource quotas are, just to kind of lay the groundwork for what they are, how they work, things to avoid. And then we'll go into IBM Kubecost 3.0, which was our latest release where we came out with some really cool new features related to resource quotas. And then we'll also have a demo of some of those features directly in Kubecost to show you how they work. And then we'll end with just some key takeaways and Q&A and things like that. And then moving on to our speakers here. So our first speaker is Joe Dahlquist. He is our head of product marketing for both IBM Kubecost and IBM Cloudability. He has a deep background in product marketing across a ton of different industries. So he's a wealth of knowledge here. If you'd like to connect with him, you will find a link to his LinkedIn there, which is also on the PDF. So feel free to reach out to him. And then our second speaker is Chip Zoller, and Chip is a product manager for IBM Kubecost. He also has a wealth of experience across cloud-native technologies, Kubernetes, virtualization, and he is our resident expert on resource quotas here. And he wrote all the docs and a lot of the resources that we'll be going over today. So he's your guy for all things resource quota. And if you'd like to connect with him, you'll find a link to his LinkedIn as well. So with that, I will pass it over to Joe.
Thanks, Dee. If you're new to IBM Kubecost, welcome. And secondly, welcome to everybody. Thanks for joining us today. IBM Kubecost built a real-time cost visibility and insights solution for Kubernetes. It's used predominantly by DevOps teams and by platform engineering teams. And we built it to help you continuously reduce your cloud costs and understand how they're being utilized, who's utilizing them, and become more cost-effective and efficient over time. Kubecost runs on Kubernetes anywhere, air-gapped, on-prem, interesting flavors of Kubernetes, and of course, across AKS, GKE, and EKS as well. Today, we're managing the spend on behalf of a great group of customers that includes Capital One, Coinbase, GitLab, Pfizer, Johnson & Johnson, and many, many more, to the tune of somewhere well beyond $5 billion. And we've got teams to support you, helping you get started using Kubecost, getting value immediately out of Kubecost across the world. So reach out to us if this is interesting to you. With that, let's move into the great content we've got today. Today, we're going to talk about resource quotas in Kubernetes. And I'm the first to admit, I'm still on a tricycle a bit when it comes to Kubernetes. And so I didn't really understand what this was immediately when we started talking about it. And we started building this feature that is now available to all of you in the newest version 3.1 of Kubecost. But when I started to learn about it, it kind of reminded me of my dog a little bit. And both Chip and Dee on the call here know that I have a big 100-pound dog. He's wonderful. We love him. Big part of our family. But he eats everything. He eats all the good food he's supposed to and too much of it. And he eats things he's not supposed to. And what I started to think about resource quotas is that it'd be nice if I had a policy that I could implement, right? Where I could tell my dog, don't eat the things you're not supposed to and only eat so much of the stuff you are supposed to. And I could make him abide by that policy while I was standing there next to him watching him. But I'm pretty sure once he ran off, he'd be right back to consuming those resources as much as he wanted to. What I really need is like an admission controller, something that's, gently and comfortably on his mouth that prevents him from eating the bad stuff automatically and make sure that he just gets the right amount of the good stuff. And resource quotas kind of work similar to that in the world of Kubernetes. These are namespace level guardrails where you can set and then enforce some governance around how much resource can be consumed, maybe CPU, maybe memory, inside of that namespace. And anything that attempts to create new resources that would request more than what those limits are set at would be automatically denied entry through that pipeline. So these are platform level Kubernetes guardrails. They can help you limit how much CPU and how much memory a given namespace can request and consume at any given time. And they help you kind of cap that CPU and memory, those important and expensive resources that can be allocated to a namespace based on what workloads declare for what requests and what limits are being set. These all get checked by an API server during this admission process, so they can block or they can create or update before it lands. This is very proactive, right? Before that bill starts to get even generated. Quotas apply across all workloads that are in that namespace. So one deployment can affect another, right? These are interlinked. They exist because you want to be able to maybe prevent a single team or a single workload from becoming a noisy neighbor, from taking more than its share and causing issues with reliability, with stability, with performance. And of course, cost as well. These are really for platform and infrastructure teams that want to be able to set this kind of governance, not really the app teams that are tuning a single service. This kind of comes in over the top very early as a quota and a governance enforcement point. That's very effective and something that we consider to be, interesting and new in this space. We can go ahead into the next slide. So how do these resource quotas kind of work, right? First, the quotas are enforced before a pod gets created, not after it's already running. So this is very preventative. This is very proactive. And the enforcement happens in an admission controller on the API server. So whether you do a create or whether you do an update, those things can be blocked immediately by this admission controller running on the Kubernetes API. There's really kind of two checks that happen at a high level. First, it looks at what's going to be declared in the pod spec after it evaluates it, right? And the second is going to be what the namespace total is, or the quota that has been set that you have to stay under, because that's the hard limit that we're talking about here, this resource quota. So what's in the pod spec, what's going to happen to this resource quota if we admit this change or this update? Quota usage is kind of something that you have to think about. It's the sum of all declared requests and limits within that namespace. This isn't real-time consumption. This is what's declared or what's being, requested. When something fails, when something breaks down, there's a way to debug that too. The deployment might look like it's fine, but the replica set or the job events might show that there's a rejection. That's going to give you an indication that something failed to pass that admission control. There's going to be other things to look at in terms of debugging, clues when this might be working exactly as you want it to, or it might need some finer tuning in a couple of other slides that we'll get to as well. You can go to the next one. So how do they actually block these workloads, right? Resource quotas are absolutely an admission control. They work like an admission control. Although this is a policy element, they can block this pod creation. They run at admission time. So in kind of plain terms, first, you get all of the required fields filled out. The quota is going to track the resource consumption that's being declared. And then every container that is declaring that either gets passed or failed based on what they would contribute to the quota of that namespace that's being set by this limit. So kind of a quick example, like if the quota tracks two resources, memory and CPU, any container that doesn't have either a memory request or a CPU request is automatically going to get rejected, right? Ones that would exceed the quota for that namespace would also get rejected. And this matters because when you add a new quota or you go to change a quota, a resource type can fail later after the pods get recreated. This is one of those things that you have to be very careful with. We'll talk a little bit more about that later. But some of the common triggers that might create this kind of a situation are rescheduling, scaling, rollouts, failures that might show up in admission events, often on the replica set or the job that is actually creating the pods are going to be indicators and triggers for this. Really quick, there's, kind of two use cases for this, two like high level ones. Either you want to add a quota, right? Or you want to tighten an existing quota to be more effective, more efficient, help you meet some resource limits that you're targeting. In these two scenarios, you might add a quota when a namespace already has running workloads, when the workload does not have a memory request that's been set. And in terms of tightening a quota, you might want to do that when the namespace is already consuming a quota, but that quota seems to not be correct. Either it's too restrictive or it's more frequently not restrictive enough, right? It can be set the same way that over provisioning requests get set, which is I want enough headroom that I don't have to worry about this. You have that happen a lot of times over, and you find yourself out of resources pretty quickly within a namespace or causing problems for other ones. Some of the things that can trigger adding a quota: a restart, a reschedule, a scale out. On the side of tightening a quota, it could be a rollout or scale up or reschedule. And some of the failures or the changes that you don't want that you might see there, you can find under those bullet points there. Either if it surfaces on the replica set or at pod creation, you're going to get some failures as well. We can go to the next one. We introduced this capability in our most recent release, Kubecost 3.1. We launched that this last January, and it includes a number of new capabilities that are really interesting. This resource quota rightsizing recommendations is one of them. It also provides you with estimated savings. So you can see by either tuning or creating a resource quota, what's in it for you from a cost optimization standpoint. You can view all this by cluster, including namespaces, either selecting to see those namespaces that do have resource quotas or those that don't. That way you can go create the ones that you need to, or look at the ones that already have them for some tuning improvements. These recommendations that we will make to you on where you should set those resource quotas are really informed by historical CPU and memory requests and limits. So Kubecost understands what some ideal scenarios would be, and we will make those recommendations and back it up with some data. You can set customizable views, whether you want to have different profiles for your production versus non-production, dev, test, and prod environments. You are likely to have different profiles for different environments based on risk, based on performance, stability, service level requirements that you might have from the business side as well. You can also really hone in on the individual namespaces based on some extensive filters. So you can isolate namespaces that need your attention and need some improvement. And then we have automation, where we can automatically apply the rightsizing choices that you make or the recommendations that we've provided, or a combination of the two, so that you can create those new quotas from scratch and be able to have instant governance essentially across that. Last slide here, and then we're going to jump into a demo. There's some great practical use cases for this. It sounds hard. It sounds complicated because this is an admission controller. The stakes are a little bit high if things go wrong. We've given you the tools in 3.1 to prevent things from going wrong. But I think these three use cases really kind of bring to life exactly how they're going to be used. First, standardization, right? Setting golden paths and guardrails across your clusters, across your namespaces, reducing that manual and often mistake, human error fraught process of updating YAML files, and being able to start from recommended baselines that have some historical data to back those recommendations. Right out of the gate, you're going to prevent a significant amount of potential waste. For SRE and ops teams, they might focus on something like making safer changes, being able to size from these historical patterns, making changes more predictable, preventing rollouts that would stall or fail or have to be pulled back due to quota mistakes. So very much use case around stability, around predictability. FinOps teams absolutely will love these capabilities because you can connect the right sizing to the waste that has been reduced and the costs that have been saved. And it allows you to kind of focus on driving capacity spend, enabling consistent guardrails across teams, having that standardization and having cost efficiency and accountability baked into it from the very get-go. So these, same underlying capabilities can really serve the needs and the pain points of different groups within an organization that are all working with containerized applications and infrastructure. I'd love to kick this now over to Chip to actually show us what this looks like, how easy it is to set this up and manage. Take it away, Chip.
Thank you, Joe. Thanks, everybody, for being here. Excited to show you what we've actually built in 3.1 and talk a little bit more about the resource quota feature and how Kubecost can really enable this technology to work for you in a way that's safe, predictable. And so let's just jump into it here. So as Joe mentioned, we have enabled a new resource quota tile, if you will, on the Savings Insights page. And you can navigate from the main Kubecost page down to Savings Insights. And if you scroll all the way down, you will see that there is a new right size resource quotas. Right size here is significant in that that's really what we're trying to do. I'll get into this more in depth, but the idea of savings is a multifold thing, and the primary use case or the enabler of savings is to right size, i.e. downsize. And so Kubecost is not just providing a front end for you to view and even create resource quotas based on manual inputs, but we're really trying to absorb what you're doing, understand it. Kubecost already understands what your workloads are doing, and pull in additional new objects like resource quotas and intelligently right size those to proactively save you money. So that said, you'll have this tile. As you can see, this is an enterprise feature, just like our GPU optimization feature is. And like other tiles, you can see an at-a-glance view of what the monthly savings might be for that. So let's just click in. And before diving in too much here, I just want to quickly talk about how we even get to this point in time. So what do you need to get here? You need Kubecost 3.1. If you have a federation of deployments that are rolled up under a single, what we call a primary Kubecost instance, your agents all need to be on 3.1 or better in order to do this, because we're taking actions across your entire fleet. This isn't just limited to one cluster. This is limited to everything in Kubecost purview. So you need to have any cluster that you want to take advantage of this on 3.1 or better with that new FinOps agent. You also need to have an enterprise license, as I mentioned, and you need to have enabled this feature in Helm. By default, this is not enabled. This is more of an advanced sort of feature here. But if you don't have the actions enabled, you'll still be able to see these recommendations that you can see here. You just may not be able to click on these buttons, and we'll tell you that at the top. There's also a component of Kubecost that enables our actions and automation. It's called the cluster controller. This is an existing component that you may have already deployed, as this is the component which delivers the container request sizing. And I'll talk a little bit more about this in just a moment. because there's some exciting enhancements coming in that area as it pertains to resource quotas. But you need those three things. You need 3.1 deployed, you need an enterprise license, the cluster controller already has to be deployed, and you need to enable this feature in Helm to take full advantage of it. Now, that said, let's actually look at this page in more detail. As I mentioned, we're right sizing here, but everything that you're seeing, although this is a test and demo environment, we're mostly showing one cluster. You can imagine that this would be across your entire Kubecost fleet. So wherever you have met those requirements, Kubecost is going to go and pull in all of those resource quotas that it detects. So let's talk a little bit about that. So already got a resource quota in a namespace. Right now in Kubecost 3.1, we are detecting what I call compute type resource quotas. Now, a resource quota, as Joe mentioned, classically addresses things like CPU and memory requests and CPU and memory limits. It can actually cover much more than that, as well as things like object counts, think like number of total pods or GPUs or dongles that may be attached, for whatever reason. But in 3.1, we're really trying to address what most customers are using resource quotas for, and that is CPU and memory requests and limits. We are pulling in existing resource quotas that are of a compute type. So they must have one of those four fields, CPU and memory requests or limits. If you have a resource quota in any namespace across any of your clusters that meet those requirements, Kubecost will see it and automatically pull it in and begin to start crunching some numbers. In addition to pulling in existing resource quotas, as previously mentioned, we'll also allow you to create resource quotas, and I'll get to that in just a second, but we're doing it in an intelligent way based on the historical knowledge that Kubecost has of your entire estate. So let's look at some of the controls up at the top. If you're familiar with Kubecost, you're familiar with the window picker, so we have the same option that's here. Very similar to other pages in Kubecost is allow Kubecost to look at your past history of workloads that are in those namespaces. And resource quotas are implicitly namespace scoped. They don't operate at a higher level. They don't operate at a lower level. So when you choose an option in the window, Kubecost is looking at, for each of the namespaces, the workloads in that namespace to determine, based on it and then other factors, as I'll just talk about, what the savings or what the right-sized value should be, and therefore what you can save as it pertains to that. We've got a profile option here with several out-of-the-box profiles. So as I mentioned, in Kubecost 3.1, we're focused on compute resources, so that is memory requests and limits and CPU requests and limits. In these out-of-the-box profiles, very similarly to container request right-sizing, we've got the standard production development and high availability. And you can also see some others that are down here. This is sort of foreshadowing some of the futures, and I'll talk about those in a minute. For the out-of-the-box profiles, we are allowing you to work with requests only, because this seems to be the most common use case for resource quotas, which is enforcement of requests. As a slight detour, hopefully not too long, Kubecost requests or requests in general are very important to costing perspective and also performance, because these are what function as capacity allocation. And on Kubecost allocation dashboard, with which you may already be familiar, we're looking at the greater of requests or usage. So requests are primarily important here to resource quotas, and that's why we've attuned these in the out-of-the-box profiles. But we understand that that's not necessarily enough for everybody, and folks want to do things like enforcing limits. So we have a custom ability. In Kubecost 3.1, you can you can define a custom profile in which you can modify any of these toggles, and then you can apply this. You can see an additional box right here when it comes to saving a name, and so I'll talk about that in just a little bit. This is a live development environment, so you're seeing some of the cutting edge features that may not be included in 3.1, but I'll certainly talk about those. As far as some of the controls here, you can see that for the requests fields and the limits fields, the metric here is locked into requests and limits. And what this is doing is to sort of talk a little bit about how resource quotas work. Resource quotas are, as Joe mentioned multiple times, an admission controller. Admission controllers only operate on what is defined in the pod spec. So therefore, usage, what the containers are doing, have no bearing on a resource quota. A resource quota is only able to take action or enforce things that are defined in the spec. And the only things you can define in the spec are requests and limits. So when it comes to these metrics, because this is front and center in resource quotas, these are the values that are really important and that Kubecost will use to look across your historical window of time that you've selected and determine what that right value is. As you may be familiar with in other areas of Kubecost, namely container requests, rightsizing, we've got a number of algorithms that can be chosen here, average, max, and then some quantiles. So, for example, some of the quantiles like P95 could be useful if you've got a namespace that's full of Java applications, for example, and you want to be able to right-size those quotas based on the requests, but a P95 of those requests. You can define then a headroom on top of that. So whatever the value that Kubecost calculates for each of the fields that you've checked off here, it will then add a percentage of headroom on top of that to the resource quota. And that's critically important because in a resource quota, you really don't most times want to be at a case where you have no headroom. If you have no headroom, that means that you can't allow any other deployments or even scaling out of an existing deployment in that namespace. So we almost always need some headroom, but just like with classical use cases in container sizing, you want that value to be uploads. Maybe you have a heterogeneous cluster where you have some namespaces which service production workloads and some other namespaces in the same cluster that service development workloads. You may have different headroom value for both of those. So this allows you to set that this in a profile. So similar thing with requests here. I've already covered all of the fields, but net here is we give you all of the power to tune any of these knobs that you want. And once you apply those values, Kubecost in tandem with the window is going to look at, in this case, the past 7 days and use the values in the profile to calculate what those numbers should be. We've got some very common filter controls, but also some new filter controls that we've built just for this page. You might be familiar in Kubecost 3.0 with the advanced filters that we've built. Those are certainly available here. Because resource quotas are a unique thing in their implicitly namespace scope, we don't need all of the filters. A couple of new filters that are very useful for you here. These two are shown at the bottom, namespace label and custom namespace label. So rather than if you have a large estate, either looking at namespaces by name or the various controls that are here, such as is not, contains, ends with, etc. You can do the same thing with namespace labels. This field, as it describes, is only going to pull in namespaces that have that label. This doesn't have anything to do with the pods that have the label, the deployments, etc. So with namespace label, you can define a key only. So for example, I could say billing. And so any namespace, effective of the value, we can apply as a filter control and have Kubecost pull in only those namespaces. But going one step further, you can also define a custom namespace label in which you define a key plus value. So maybe we have billing of HR, just making things up. So now Kubecost will pull in only the namespaces that have the specific label billing equals HR. So you can imagine across your entire Kubernetes fleet to which Kubecost is connected, you could have thousands, tens of thousands or more of namespaces, and maybe you're using resource quotas today, maybe you're not, but you can really hone in on what the scope of operation that you're interested in doing here. So I'll just go with the defaults. And then finally, the last control here. This is great for teams that maybe if you're already using resource quotas and you want to just, all right, I want to get immediately down into right sizing. I don't want to deal with anything else. you can do that. Namespaces with resource quotas only will return only the namespaces across your affected a resource quota. And I mentioned earlier what those criteria for detection of a resource quota. By the way, this is, as you can imagine, dynamic and ongoing in the spirit of Kubecost, in that if you have additional namespaces in the future, if you have manually created a resource quota in the future, once Kubecost collects that data, this query will update with those new namespaces and the new resource quotas. So it's not like you have to do anything manual. Kubecost will pull those in next time that you visit the page. But with these two filter controls, you can isolate even further the scope on which you want to operate. So if you already have resource quotas and you want to just get down to brass tacks and start saving money and resizing them, you can do that easily. Alternatively, if you have already done that and you want to focus on namespaces that do not have resource quotas and use Kubecost's intelligence to begin creating and applying some of those guardrails, you can do so with without namespaces without resource quotas only. Now, as you can see here, the savings has dropped to 0. You don't have a resource quota. There's no savings opportunities because we're going to create one for the first time. So that's we want to enable you to do both of those things, not just save where there's already things that are being consumed, but get you on the path to some guardrails that allow you to then start introspecting in that namespace, which then enables you to tighten the reins and then start saving even further. So journeys, no matter where you are with resource quotas today. Let me flip back to the all option. And let's look at some of these values here. So you can notice previously that when I toggled these options, I had the apply option, then I had namespaces without resource quotas. We can create resource quotas. So I mentioned at the outset, what we're trying to do here is not just a simple front end for, hey, let me create a resource quota. We want to do better than that. We want to provide you an ability to apply a recommendation or create a resource quota based upon our recommendation. So we go immediately to the value point. And then we can extend that further by continuing to optimize and resize those quotas. So looking back at this main table, I'm looking at a cluster here, and we've got a namespace called Project Resource Quotas. This is the name of the resource quota that Kubecost has detected. All of the quota types today are compute quota types. We may extend this to others, for example, storage in the future. But for right now, most of the users out there that are using resource quotas are really focused on compute. So all of the quota types are going to show as compute. And then we're looking at efficiency. And now we're showing two efficiency numbers here, one for requests and one for limits. We do that very specifically because you have CPU and memory as well for requests and limits. So we have a weighted average on what the total efficiency is for both of those rather than trying to combine them into one. You can see here we have a dash. So in this case, the existing resource quota does not have any limits. So we don't have a limit to show or an efficiency to show on that. And a possible monthly savings that you can realize by resizing and applying the recommendation here. So you can see a little accordion view that I took the little chevron here and expanded this to show more information, some existing information, but let's look at the information in this quota. So our production profile, if we go back here just as a reminder, we're defining only requests for CPU and memory. So that's what Kubecost is producing a recommendation for. Maybe you do have some resource quotas that define limits, or maybe you just want to isolate even further and say, okay, I'm only interested right at this point. I can expand it later, but I only want to focus on applying recommendations based on, let's say, memory requests. You can totally do that in a custom profile. It will leave all of your other fields alone. So you don't have to have fear that, oh, I have to go with exactly what Kubecost is saying and it's going to wipe everything else out. No, it's going to leave your quota exactly as is and only control the fields that you tell it to control. So in this case, we want it to look at CPU and memory. That's what we're doing. This is a resource quota that exists in the cluster. So we've got, for the CPU requests, we've got 20 CPU, and this is the currently used value that's being reported in that quota. Recommendation based upon your profile and the efficiency of that, as well as the savings for each of these line items. So you can see here, if we were to go and change this from production to, let's say, high availability, and we need some more headroom here. We're going to go to 50% headroom. Well, that's going to adjust the values that Kubecost is computing. So you can see here, things are going to be less. So you can see how real time is going to recompute the recommendation. But let's go back to production here. And having an at-a-glance view of Kubecost recommendations is going to give you a sense of whether this is going to work for you. We can click the apply button here, and we can now opened. Kubecost is just going to let you know that, hey, you're going to reduce a resource quota. Just let you know that that's going to happen here. If you're good with all of the values, you can click apply. You can also take this opportunity to say, okay, I know that the profile had these defined, but maybe I just want to go with memory requests rather than going back and starting over with the profile. Maybe I just want to accept the memory request. So I can expect that the current number, which is currently set to 20 GI, 14 and change. So I'm only going to accept that recommendation. Kubecost is going to leave everything else alone. We can click that recommendation, and you can have dispatched that recommendation. So Kubecost is using the same mechanism that it uses today when it comes to applying all of its actions. If you're familiar with Kubecost and how it does that, it's a centralized bucket. This is really great for risk-averse teams and really just security in general, in that we're dispatching a secure order, if you will, to your centralized S3 compatible bucket. And the cluster controller in those clusters will see that there's a work item for them, pick that up, ensure that it's securely signed, that it only comes from a trusted Kubecost instance, and will apply that. So generally, this takes a few minutes to apply, so we won't see the change reflected here immediately. But if you were to refresh the page in a couple minutes and you come back, you may see a different recommendation here because the value will have been adjusted. So if we were to come back after a couple minutes time and look at this resource quota again, we would see that the current value now matches the recommended value. So that is the flow when it comes to applying recommendations. Create resource quotas. We can do that with this easy toggle. Similar thing applies, so I won't bore you again with all the details, but based on a filter, if you want to say, all right, in this namespace, I don't have a resource quota, I want to get started and come up with a way in which Kubecost can tell me, all right, look across the last 30 days in this namespace, requests that have been defined for all the pods that you saw, and come up with a recommendation that, with some of the headroom that I specified, gives me a good level of control of where to start. That's exactly what we're doing here. So you can expand and see that the used value for now these are the CPU and memory requests that are defined in the pods that it saw in that window. If you didn't have pods that defined CPU and memory requests, hopefully you're doing that. If you're not doing that, by the way, Kubecost container request rightsizing is a great way to start, and I'll talk about how we're enhancing that in the future. But you can get some requests. You should have some requests in there. Kubecost can then pick those up. So similar type flow here. We're just going to remind you that, hey, we're going to create a new resource quota. It's going to require that all containers include those fields shown, both current and those in the future. So you just want to be at resource quota. Similarly, you can select only the fields that you want. You need to be able to create that quota. You can't create an empty resource quota. And then you click create. So in a nutshell, that is how and what we're doing to enable you to really start getting both started with resource quotas and saving with resource quotas. Talk a little bit about the futures as it pertains to resource quotas that are coming not too far in the future, and then turn it back over to Joe to talk about some of the other enhancements that we're planning in Kubecost. So what's next? You just saw a demo of the resource quota feature. Let's talk about what we're doing first. What's next in resource quotas? So I mentioned or alluded to this earlier, we are enhancing the container request right sizing feature in the very near future to bring in resource quotas to that. So now, or soon rather, you will be able to, in one fell swoop, right size your container requests and synchronize whatever those changes are with the resource quotas that exist in that namespace. So this is going to be super powerful for enabling you to really create a self-driving machine that operates on a cadence. You basically set and forget and know that your workloads are properly sized and that your guardrails in the form of resource quotas are synchronized and are maintained and don't get too out of whack, so that you're always having the same type of governance that you want in that namespace. We're going to allow role-based access control, Kubecost teams. You'll be able to create specific roles for the savings insights page that I just covered. We're also enhancing the audit log to bring in changes to the resource quotas, as well as greatly enhancing the audit log in its entirety. I'm excited to tell you about that in the future. And lastly, and you saw a little bit of this in the live environment, we are going to allow persisting of custom profiles. So you can save a custom profile for a resource quota and reuse that at any point in the future, as well as consuming that in the integration with container right sizing. And so with that, let me turn it over to Joe, and he'll go over some of the what's next outside of resource quotas in Kubecost.
Thanks, Chip. In addition to those great changes and updates, enhancements, and new features that are coming forward, we've got a lot that's on the roadmap that we're going to be delivering here. First kind of category, AI. We are adding support for new hardware, new GPU hardware. We're implementing dynamic, intelligent auto-scaling capabilities and some automated GPU optimization that goes further than what is already in Kubecost 3.1. If you've been paying attention, we recently launched Cloudability Advanced Containers. That is a SaaS implementation of Kubecost capabilities powered by Kubecost natively within Cloudability's SaaS solution. That kind of helps to bridge that gap between FinOps teams and DevOps teams. We're going to be doing deeper integrations with Cloudability, adding great features like to support things like multi-tenancy. In terms of governance and creating more of these powerful guardrails, we're looking at integrations with Terraform and more CI/CD pipeline providers. We're looking at enforceable budgets and network anomaly detection. That'll all help bring cost anomalies, cost aberrations, costs you don't want to your attention either proactively or much sooner. And we've got some enterprise improvements as well to support new billing exports like AWS's Cur 2.0 and to be able to support some additional cost metrics. With that, we can wrap it up with some of the things that we hope you take away from this. And maybe I'll grab the first couple and Chip can jump in on the other. Kubernetes enforces quotas on declared requests and limits. It's not like on real usage. So this is very much before resources have been consumed. That's something important to think about. This is like enforceable planning stage capabilities. The next, you should be right-sizing your request first, right? You don't want artificial or unnecessary pressure being put on those quotas once you implement them and then have that show up later as something like a blocked rollout because a pod doesn't get created. So do some right-sizing requests first to try and ensure that the utilization that you're seeing is appropriate and that the quota you're going to set in turn will also be appropriate. And then use those quotas to kind of protect reliability first, right? This can absolutely be used to prevent that noisy neighbor impact, to ensure that you've got non-over-provisioned resources that can have a detrimental effect on performance and reliability as well. Then turn to optimizing efficiency and cost.
Yep. So resource quotas need to be set with historical context, right? Just setting them with a static value doesn't work long term. We need to be able to look at an intelligent amount of usage and apply some level of intelligence to understand what we should be doing. So that's critical with resource quotas. We need to understand namespace requests when it comes to real usage before tightening those quotas. This is critical because if you don't have an understanding of what workloads are doing in that namespace and what you're going to deploy in the future, you may get into a situation where you're bumping your head on the ceiling when you really shouldn't be. And lastly, applying quota updates as small incremental changes, not emergency fixes. This is something that Kubecost 3.2 is going to help even further with, but you really need to be able to make changes to resource quotas that are not in, dropping the hammer, if you will, on a resource quota to say, all right, we're going to just, chop this thing in half. And that goes to the intelligence and the historical aspect that you need to have, and Kubecost provides you. So having this whole story complete is really going to be the best way to manage resource quotas going forward and to really optimize for cost.
Awesome. Thank you to both Joe and Chip for walking us through that. So just wanted to end with some quick resources. So if you download the PDF version of today's deck, we do include a link to the main Kubernetes documentation about resource quotas, so you can dig in a bit further to really understand how they work and better understand some of those gotchas that we covered at the start of the webinar, just to ensure that you're using them correctly before you actually start diving in to optimize them with Kubecost. We also have a link out to our recent blog about Kubecost 3.0 that provides some additional details about what we covered today, and our own doc site that has all the nitty-gritty details of how to actually use the resource quota features within Kubecost, in addition to how to ensure that you enable everything correctly so you can actually take advantage of the automated actions that come with that. So feel free to dig in there to learn a little bit more. We do have some time for Q&A. There weren't really any questions submitted live during the webinar, but we did have some that were pre-submitted. A couple people had questions about just kind of feature improvements and enhancements in Kubecost. Hopefully we covered the answers to those questions during the roadmap slide. But we did have one question specifically that was about our future integrations with Turbonomic. So if you're familiar, Turbonomic is another great tool that kind of falls under the FinOps suite of IBM tools here. And so we have some integrations of Turbonomic with Kubecost currently that are on our savings, insights, and actions pages. But we will be expanding some of that integration with Turbo a bit deeper. So I'm not sure if Joe or Chip, maybe you have any additional insight onto what some of those integrations might be.
Yeah,
I'll just go for it, Chip. Yep.
Sorry, yep. We're still rapidly trying to understand what matters to you all. There are lots of things that we're investigating here. We don't have any super firm plans on which exact areas that we're going to bring in, but we definitely know that this is an area of interest, and we are looking at deepening the relationship and pulling the seams together, if you will, across not just Turbo, but Cloudability and others.
Yeah, agreed. And I think folks should take a look at the integrations that we currently have with Turbonomic. They're really impressive. Turbonomic does, application resource management using automation. What Turbonomic has not historically had is the concept of cost. If Turbonomic recommends to you 200 actions that you can take, all that will result in some optimization, Kubecost can now help you prioritize those based on what the positive impact of cost savings would be for each one of those potential recommended actions. And then you can, move forward with some degree of confidence, knowing that you're working and prioritizing the right things for optimization. So I'd encourage everybody to take a look at the integrations. We've got that there now. As Chip said, please provide us more feedback if there's integrations that will help you solve your day-to-day challenges or pains. We would love to hear about that.
Yeah, and just closing off with that, if you do have any feedback to share, we're always happy to take it, because this helps kind of guide our product roadmap and plans for new things that we want to investigate. So the best way to do that is you can email our team at team-kubecost@ibm.com, and we will make sure that we get whatever your feedback is in front of the right folks. But you're also welcome to join our Slack community. We have a Slack community link on the console there, so feel free to join there, and you can meet with other users that are using the product and get questions answered. But it's also a great place for you to connect directly with our team and the experts on the team to answer any questions you have, any feedback you have, or just general knowledge sharing that can help you use the tool better. So with that, thank you so much for joining us today, and thank you to both Joe and Chip for their time today. And we hope you all have a good rest of your day. We'll see you next time. Bye, everyone.